All right, thank you for being here and deciding to join my talk. It's really hard to see with all the bright lights, but there's a couple of people. A quick show of hands. Who is here because you are an SRE? And who is here because you want to find out what the fuck is SRE? Okay, you raised your hand twice, so you are an SRE, but still don't know what you're doing? Okay, my name is Andy Grabner. Thank you for the introduction. During the day, I work for Dynatrace, so in case you're interested in what we do at Dynatrace, my colleagues are downstairs. But really today, I'm representing the CNCF, the Cloud Native Computing Foundation. I'm one of the ambassadors, and I also am a maintainer and a founder of Keptn. I'm wearing it with pride, as you can see here. Everything I show you today is all open source. That means I don't sell you anything. I just really think I can give you some ideas on how to solve some of your challenges as an SRE as it comes to observing the stuff that is happening in your environments. The title is Don't GitOps into a Black Hole Using SLOs and Get DORA the Kubernetes native way. If you stay with me, I hope you're not afraid of YAML. There will be YAMLs, there will be different tools, there will be terminal windows. We adjusted the screen size earlier. We try to make it as big as possible, but for the people that sit in the back, unless you have really good eyes, stay there. Otherwise, feel free to come forward. But I understand just before lunch, you may want to sit in the back. Here you go. There you go. Ah, that's good. All right. I know. Yeah, here we go. Now we have a movement going on here. It's nice. All right. So we see a lot of live demos. And don't be scared. There you go. There's more seats in the front row, second row. Because I can tell you, I'm 40 plus and my eyesight is really getting worse and worse because I was always sitting in the back. That's why I think in the future. Okay. Quick pulse. I want to get a quick pulse of the audience. Please raise your hand if you're using or intending to use Kubernetes as your standard platform. All right, that's good. Second, OpenTelemetry. Who has heard about OpenTelemetry? Is using OpenTelemetry? Also good. Pretty much the same hands. GitOps. All right, what is GitOps for you? Yeah.
GitOps.
Yeah. What is? You say you raised your hand. You're interested in using it. How do you use GitOps?
We use ArgoCD to actually point our deployments in Git.
Okay, perfect. Desired state management, you have a desired state in Git, and you have tools like ArgoCD or Flux or any others that are then applying the desired state to the actual state, and you hope that the desired state will become the actual state and stays there. Okay, perfect. DORA metrics. Of course, you have to raise your hand. Guy from Google. Who else raised your hand? I didn't see this. 1, 2, 3. So DORA are 4 key metrics that kind of are used to measure the adoption and I think the maturity of DevOps adoption, deployment frequency, deployment failure rate, failures of deployment, and time to restore service. So these are 4 of the metrics that are typically used when we figure out, do we actually do the right things, and are we moving forward with all the millions and millions we put into the tools and the people we educate. Right? So DORA metrics. Another one, SLOs. Who is using SLOs, understands SLO, service level objectives? What is a good SLO? Give me an example.
Well, something that's relevant to your customers. So I guess the availability of your service. Availability classified as probably a both latency limit.
Perfect. I'll try to repeat it and condense it down. But you said, the very first thing you said, something that is relevant to your customer. For your customer, it's not relevant if your CPU hits 85%. For your customer, it's important that your system is available and that they can do the things that they want to do in a manageable amount of time. So performance is typically key. Latency, I think, as you said, also failure rate. Things should work as expected. So SLOs. And the last thing, has anybody heard about Keptn before and maybe even using Keptn? Or is this completely new? All right, you get all converted today. Perfect. So I have 3 major agenda items. First, or 3 major use cases that I think are challenging for SREs these days. First, observability tool sprawl. What that means, you have many tools of choices when it comes to observability. The challenge is, how do you connect all of the observability tools to your tools that run in Kubernetes that actually make automated decisions? So if you think about, you mentioned Argo. You're using ArgoCD, but you maybe also use Argo rollouts for canary deployments. Yes. Argo rollout need to make a decision based on data on good or not good, right? But the question is, do you have one observability tool or do you have multiple observability tools? Different teams use different tools and they sit somewhere outside. So I want to talk about how we can solve the problem that while we have standardized with OpenTelemetry on how to ingest data and observability, we want to bring a standard back to Kubernetes that allows you to consume observability data in Kubernetes regardless of where it's stored and where it's managed. Second one is unmeasurable change impact. We heard about this. The challenge is it's really hard from an Argo perspective, I think, if you're deploying a complex application and it fails or if it's slow, how to troubleshoot it, right? Because you can look at logs, you can look at pods and all the events. But I will give you a demo on how we are extending, how you can extend the Kubernetes pod scheduler, which is at the heart of Kubernetes, and actually get telemetry and traceability. So I'm going to show you how we can create OpenTelemetry traces as Kubernetes is deploying the changes that ArgoCD is pushing out, right? And then you can use it for troubleshooting, but also you get your DORA metrics. Last one is, I call it pipelines gone wild. I think it's really hard I have to point, what's your name, by the way? Mohammed. It's great that we have tools like Argo, but you may not only have Argo, you may have other tools as well that you're using to deploy and to enforce testing, security, observability across all of these different pipeline tools is really hard. So I want to show you also a way how we can natively in Kubernetes, in the pod scheduler, enforce security, observability, and tests. Good. So the first one, even though I already hinted on it, so I have always one slide for the use case or the challenge and then a demo. Observability tool sprawl. As I mentioned, you may have multiple observability tools on top. Prometheus, Dynatrace, Datadog, New Relic, Honeycomb, whatever it is. And you have tools on the bottom like Argo that need access to this data to make a decision. And the challenge right now is that if you look at HBA or CADA, right, for auto-scaling, you have different plugins. Or also for Argo, there's like 2, 3, 5. For every observability tool, there's a plugin. And if you're building a pipeline, if you're building a platform, you need to somehow figure out if a new observability tool comes in, how do we connect this to all the other tools that need to make observability-based decisions? And that's why I always call it, observability tool sprawl. We need to have a standard for this. And the standard I want to propose is coming out of the CNCF project that I'm representing. It's the Keptn metric server. The Keptn metric server basically specifies a standard on how you can pull in any type of observability data back into Kubernetes and make it available through either Prometheus or the Kubernetes metrics API to all of these tools. It solves a major problem, actually two, I think. First of all of these tools vendors on the bottom, they don't need to provide and build plugins for every point-to-point integration. And on the other side, it also helps the observability vendors to not have to build and maintain these point-to-point integrations. So how does this look like? A quick demo. So my demo got, and I got a wired connection. Let's see if this works, but my screen just went by. All right. So what do I have here? Just to show you what I've installed. I have installed on my Kubernetes cluster. I just run K3s. It's a lightweight Kubernetes cluster on an EC2 machine. So I just have an EC2 machine out there. K3s is installed. The whole demo, the link I'll give you later as well. If you install Keptn, there's different components that come with it. The one that I focus on right now is the so-called Keptn metrics operator. You can only also just install this component, and then you get this use case that I'm showing you right now out of the box for free. So the metrics operator, what it does in my Kubernetes cluster, it is watching out for things that get deployed, in my case, with Argo. So this is ArgoCD, in case you've never seen it. What I have in my first use case, I have a Git repository here. Just as you, Mohammed, in your environment, I have a Git repository with a bunch of files, and they're automatically, it's my desired state, and pushed over to Kubernetes. And to show you how the metrics piece works, the only thing you need to do is you need to tell Keptn what is the metrics provider. So I have Prometheus as a metrics provider, and I also have a second metrics provider. I do work for Dynatrace, so I have a Dynatrace metrics provider. We already have a Datadog metrics provider and AWS CloudWatch. Somebody's currently working on Honeycomb and New Relic. So building a new metrics provider is very easy. It's about 20 lines of code. It's just translating a query to an API call of that target tool. So you specify what is your data source, and then you specify what type of metrics do you want to pull in. And hopefully, again, this is big enough. But you can see here, I have a Keptn metric that's called available CPUs. And I pull it in from Prometheus, and here's the PromQL query. I have a second metric that is called availability SLO, a service level objective. This, in my case, comes from Dynatrace because I use Dynatrace for SLO management. And so here's the query against Dynatrace. The beauty is Keptn metrics operator is basically constantly pulling from Prometheus, from Dynatrace, from Datadog, the data in, and makes it available to me in Kubernetes. So one way to check this out, I'm just doing a kubectl get Keptn metrics. You can see here, these are the two metrics I specified with the current value. So we're exposing these values through Prometheus. So if you have, most of the tools that are out there in Kubernetes, they have a Prometheus integration, so you can fetch it from there. The other thing we do, we also expose it through the, as I mentioned in the beginning, the Kubernetes metrics API. Tools like KDA, I'm not sure if you're familiar with KDA and HBA, the horizontal pod scheduler, and KDA is also for event-driven scaling. I can now use these metrics to specify how to scale. So no longer am I limited to just data that I have available within Kubernetes. I can now pull in data from external sources. And to your, what was your name again? Evgeny, you mentioned what matters the most are SLOs that are close to the end user, like availability. So now what I can do, I can specify a, where's my scaling? I can specify an HBA configuration horizontal pod scheduler, and I said, I want to scale my deployment based on the availability SLO. And the nice thing about this is, I don't need to specify here anymore that this comes from Dynatrace, and maybe tomorrow I switch to Datadog or to New Relic or somewhere else. As an SRE, I can specify these are the metrics I want to pull back into Kubernetes and give it to the tools that need to make data-driven decisions. So we are separating the concerns of what data I need and where the data comes from. And we provide an open standard for this. Okay? Make sense? And you can change it behind the scenes, yeah? Yeah. And the thing is, right, your developers, maybe they define their scaling rules based on whatever metric, but they may not know what your observability tool of choice is that you are putting into the platform. They don't need to learn PromQL or Dynatrace query language. Yeah? So it's separation of concern here is nice. So that's the first demo and the first use case that I highlighted. The second use case that I have is unmeasurable change impact. So I assume, putting it when you do with Argo makes changes, but maybe you have other tools that make changes. Maybe you have somebody even that dares to remote into a machine and then makes changes with kubectl apply or something like natively. That means you have multiple tools that make changes to application layer or to even infrastructure layer, right? Your ingresses, your service definitions, your deployments, your workloads. And then the question is, it's really hard to figure out why did this deployment all of a sudden with Argo take 5 times longer than yesterday? What else changed and what else is going on? There's no real great visibility into this. One solution we also bring in with the Keptn open source project is what's called the Keptn lifecycle operator. The lifecycle operator extends the Kubernetes pod scheduler. Now, if you're not familiar with the pod scheduler is the component in Kubernetes that says somebody wants to deploy a pod, I'm trying to figure out where are the right resources and then put it there. But we can extend it through plugins where we can do additional things. The basic thing we're doing here is actually figuring out and monitoring and measuring what the pod scheduler is doing. What is it deploying? How long does it take? Technically, how this looks like, right? Some technical details here. If you're deploying, let's say 3 services, then what we can do, we can measure the time from before the deployment actually happens. So as the pod scheduler tries to find the right spot and then deploys it, so we can do pre and post, which means we can create metrics, timing metrics. But what we also do is we are looking at metadata on your deployments, and we can say, hey, front-end, back-end, and storage, they actually belong to a bigger application. So I really want to monitor and get insights into everything that changes in context of an application that I'm changing. And therefore, right, we can also measure in the end-to-end time it takes for the whole app to deploy and the individual components. And the way we are exposing this is through OpenTelemetry. So I'll give you a demo. In my environment, my simple node environment, the only thing you need to do is in order to enable this, the only thing you need to do is on the namespace where you deploy your app. This my namespace is my simple node. It's a simple node app. It's my dev space. You need to enable the lifecycle toolkit. So that means if I go quickly back to my Keptn installation, in my Keptn lifecycle toolkit namespace, there is the lifecycle operator. Right? That's really the thing that is now extending the pod scheduler. But it's only getting active if you have the namespace annotated with that you want Keptn to become active. So by simply doing this, and if I go in now, and if I go to my deployment, and if I make a change here, I'm just making a simple change. I'm changing my version. I'm just bumping the version here. I'm not deploying anything new, but I'm bumping a version. V602, commit. So what happens now, for those people that know Argo or Flux, Argo will say, hey, there's a change, I need to sync it. There we go, right? It's out of sync, so the desired state is a mismatch, right? And now it basically says, hey, Kubernetes, I want you to deploy this. As this is happening, Keptn detects this namespace is monitored by me. You can see here, Keptn actually creates a new object. It's called the, hard to see probably, but it's the Keptn workload instance. It detects there's a new version being deployed. This runs a little bit. I have 13 minutes left, and I will come to the full details in my last demo. But to a quick peek forward, what we are doing, what Keptn does, it is creating a trace, a distributed end-to-end trace of everything that we now see that the pod scheduler does in the context of that deployment, of that sync. Right? So one of the things we have is we first of all get some nice metrics, the DORA metrics, at least some of them. Things like how many deployments happened in my last 6 hours that I did, time between deployments, deployment time per version, average time between deployments, successful, failed. And what you also see here on the bottom, these are the actual traces behind the scenes. So for those of you that know OpenTelemetry, the key use case is actually to trace transactions from your business apps, from when you're hitting a URL and then tracing it all the way through. But what we are doing is we are using OpenTelemetry to trace a kind of like a business process, because deploying your change is kind of like a transaction. You're asking Kubernetes to do something. So what we are monitoring here, what we're creating is an end-to-end trace of everything we see the pod scheduler does. There's a little bit more in here that I will explain in my third use case, but we are showing you, hey, it took 1 minute and 25 seconds for Kubernetes to actually deploy this particular workload. There are some additional pre- and post-deployment checks that I come to in a second, but this allows you to figure out how long did it take, why did it fail. If it fails, all of the events are also here. Everything will be shown here. It's a nice trace, giving you observability into your deployments. Okay? Good. 11 minutes left. Brings me to my last use case. I call it pipelines gone wild. Why are you smiling now? So pipelines gone wild. The thing is, we need to enforce different things, different policies in our organization, right? You want to run functional tests, security tests, you want to validate. Now, one option is that you go to all of your development pipelines, all of your tools, and try to fit this in and enforce these pre- and post-deployment checks. But it's really hard. And so what we bring to the table, again, with the Keptn lifecycle operator that sits in the pod scheduler, so everything that is deployed, we have an option to actually stop the pod scheduler before it deploys your pod. We can execute actions, and we can do something afterwards. So we can actually natively bring pre- and post-deployment checks into Kubernetes. And then it doesn't matter if you're using Argo, Jenkins, or if somebody does a kubectl apply, we can enforce these checks natively. No, there's no way around it. Nobody can bypass it. All right? So if you think about this slide again that I showed earlier, where I explained we're using this to measure the end-to-end deployment time and trace, we now give you the options to execute pre- and post-deployment. We call them tasks and evaluations. There's 2 types we allow you to do, and I'll show you in the demo how this works. So if I go back to my demo, 10 minutes, yeah, thank you. If I go back to my demo, this is the stuff that let me just refresh here quickly. Here we go, right? This is the version that I bumped up to version 6 earlier. If I scroll a little further down, you can see here there's some additional annotations called Keptn pre-deploy evaluation, pre-deploy task, post-deploy evaluation, and post-deploy task. So we allow you to specify tasks and evaluations. And I want to show you what these are. I start with the evaluation. The evaluation is a metric-based evaluation, but again, using our Keptn metrics. That means here I have a Keptn evaluation definition called evaluate dependencies that are linked for the pre-deployment. And I basically say, hey, Keptn, whoever deploys, I first want to make sure that my available CPUs has an evaluation target of bigger than 4. Wherever this metric comes from, I don't care because the SRE team has figured this out, how to craft the PromQL. But this is my pre-deployment task that I want to have evaluated. For the post-deployment, I have my evaluate deployment. This is where I say after the deployment, I want to, again, validate that I still have enough CPUs. And I also want to validate that my availability is more than 90. So now I can combine multiple metrics from multiple different tools, but I'm using a single, simple standard, and everything is done natively in Kubernetes. So that's for the evaluation piece. And then the task piece, there's also Keptn tasks that we allow you to write. Basically what it is, we allow you to specify a TypeScript function that we execute either pre or post deployment, depending on how you define it, where you want to call it. We call this function and use, I'm not sure if you're familiar with the Dino runtime. The Dino runtime is a lightweight runtime. So we run this code for you in your namespace, pre and post deployment, and then we give it some data, some secure data. I'll show you this in a second what it is, and also the context. The context would be what's the workload name, what's the version. So basically, this function gets executed in the context of a current thing. And then the security piece. My example here is sending a Slack notification. And the Slack token, right, that just gets passed in as a security token. And that's the security piece on top that comes in. So that means if I did everything correctly, then if I go back to my deployment, pre-deployment task was notify and post-deployment, so the same function was called twice. And if I go in here into my Slack channel, I see that at 1:47 p.m. I'm on Central European time. Version number 6 was the pre-deployment message and the post-deployment message. So that came in. Whether I do it with Argo, with Jenkins, with Flux, or kubectl apply, Keptn sits there and executes my code. And then the other thing that should have happened is, first of all, Argo. If I do the refresh here to make sure that I see really everything, Argo has also visualized this nicely for me. Here's my Keptn workload instance. There's the post, the post notify, pre-notify. It shows me everything that has been executed. And if I look at the post notify evaluation, we also show you exactly, hey, the availability SLO was successful because it had a value of 99.95, and the CPU was also successful because of the value of 8. So I also get the full trace and trail of what actually was evaluated, why it was successful, why it failed or not. Right? And going back to my dashboard, I have all of my deployments, my deployment time. Version number 6 took 116 seconds in total. I have the trace for version number 6 here as well. And in that trace, and this now explains why the trace is rather extensive already. You can see here, we also have the pre-tasks and the post-tasks showing up in the trace as well. Because if you're putting logic into the deployment and we execute code for you, then you also want to know how long does it take? Does it fail? Everything fully traced. And you can look at this data here, or your OpenTelemetry. Most tools understand OpenTelemetry. Right, you can pick your tool of choice to look at this data. So to wrap it up, I think there's 3 challenges for you as an SRE today or tomorrow, right, depending on how far along you are in the journey. You're building your new platforms for your organizations. The tool sprawl, the unmeasurable change impact, and pipelines gone wild. And with Keptn, we show you an open source way to to counter these challenges. Right? And the nice thing is, I know there's a lot of observability. This is the observability track. In the end, it's all about making things observable, because you need the right data in case something fails. But you also want to use observability to make automated decisions. And that's exactly what this is all about. So we have 4 minutes and 43 seconds left. And thank you so much. And if there's questions, I'm happy to take them.